Good morning, students. Welcome to today's lecture on cryptography and network security. Cryptography is defined as the process of converting plain text into ciphertext. Plain text is the original message that we want to hide, and the ciphertext is the output of the cryptographic process. Cryptography is basically classified into two types. One is the private key cryptography and the other is the public key cryptography. Private key cryptography uses single key for converting plain text into ciphertext, whereas the public key cryptography uses two keys. One is the private key, which is kept confidential, and the other public key, which is announced publicly for hiding the message. One simple example of public key cryptography is an email system, where an email ID is announced publicly and a private key, which is our password, that is kept confidential. There are quite a number of private key and public key techniques available in the literature. We are going to discuss some of the techniques commonly used in each of these two categories. We will begin with the private key cryptography. The first private key cryptographic technique that was studied was the Caesar cipher. This is one of the simplest and the oldest techniques and was invented by the king Julius Caesar. The reason this technique is called simplest is because the key value is always 3. Private key cryptography is otherwise called as symmetric key cipher. This is because it uses only one key for both encryption and decryption. It is classified into substitution cipher and transposition cipher. Substitution cipher can again be classified into monoalphabetic cipher and polyalphabetic cipher. Caesar cipher is a monoalphabetic cipher, and there are a number of polyalphabetic ciphers. I can give you a number of examples: auto key cipher, Playfair cipher, Virginia cipher, Hill cipher, one-time pad, and Rota cipher. We can also divide symmetric key cryptography in another method. One is the stream cipher, another one is the block cipher. In stream cipher, encryption and decryption are done one symbol at a time. In block cipher, a group of plaintext symbols of size m, where m is greater than 1, are encrypted together, creating a group of ciphertext of the same size. Examples of block cipher are Feastel cipher, Des, Hill cipher. Auto key cipher. It is a cipher that incorporates the message into the key. That is, the keyword is concatenated with the plaintext itself to provide the running key. It starts with relatively short keyword and appends the message to it. Hill cipher. It is a polyalphabetic cipher based on linear algebra. It was the first polyalphabetic cipher in which it was practical to operate on more than 3 symbols at once. Since it can encrypt more than one character at a time, it is a block cipher. In this, each letter is represented by a modulo 26. To encrypt a message, each block of n letters is multiplied by an n cross n matrix. To decrypt the message, each block is multiplied by the inverse of the matrix used for encryption. Playfair cipher. It is a multiple letter encryption cipher which treats diagrams in the plaintext as single units and translates these units into ciphertext diagrams. The Playfair algorithm is based on the use of 5 cross 5 matrix of letters constructed using a keyword. One-time pad. It is a type of encryption which has been provided to be impossible to crack if used correctly. Each bit or character from the plaintext is encrypted by a modular addition with a bit or character from a secret random key or pad of the same length as the plaintext, resulting in a ciphertext. Since the key is truly random, it becomes impossible to crack without knowing the key. Rotor cipher. Imagine how an electrical typewriter or a computer works. When we press a letter on the keyboard, a signal is sent along a wire and that letter appears as the output. Now suppose that the wiring was connected up in a different way, then we will be able to write a different character corresponding to the letter that we have typed on the keyboard. Special ciphering mechanisms which take advantage of this idea are made with several wheels, usually known as rotors. The rotors are also able to turn independently so that many millions of different ciphers are possible. Feastal cipher. It is a special class of iterated block ciphers where the cipher text is calculated from the plain text by repeated application of the same transformation or round function. In this, the text being encrypted is split into two halves. The round function f is applied to one half using a subkey and the output of f is exclusively OR with the other half. The two halves are then swapped. Each round follows the same pattern except for the last round where there is no swap. A nice feature of Feastal cipher is that encryption and decryption are structurally identical, though the subkeys are used during the encryption at each round are taken in reverse order during decryption. Data encryption standard, otherwise known as DES algorithm. DES algorithm takes a fixed length of plain text and converts it to a series of operations into ciphertext of the same length. Here the block size is 64 bits. The key used in DES is also 64 bits, but the 56 bits of the key is used. The remaining 8 bits are used for checking parity. Thank you.